Okay, so motion correction, as I mentioned, will be pretty quick, and after that, you'll be ready for lunch. So to make it more fun, I'm gonna do something catastrophic. I'm gonna mimic a kernel crash or something. Something happened, so you have to restart the kernel. So I'm gonna go ahead to kernel, restart, and clear all the output. Don't be afraid. You can just do the same. We should be able to catch up without redoing whatever we just done. So now, okay, I guess we have a clean kernel. Every single variable that we were just working with are lost in memory. So what do we do? Well, first of all, we make sure we run these 5 cells in the setting up, right? So go load the modules, define the parameters. Notably, we already have these 2 handy parameters here that we wrote down. Of course, I script this, so I know this when I do it. So, but this is the benefit of kind of writing it down. So in case you need to restart a kernel, that you have this. You don't have to redo anything, or you don't have to redraw the box or anything. So go ahead and run this cell. These 2 variables will be defined, and then do the import, do the initialization, and start the cluster. Okay, so now after this, we have a sort of fresh kernel with some minimal things defined, of course, but none of the VR array or whatever were available to us anymore in memory. So what happens, like what you do if this happens? So whenever you see a save result, or basically a save minion call, it's actually saving something to the hard drive. It's either saving to the intermediate path, like intermediate folder, or it's saving to the actual final result folder. Most of the time, it's saving to intermediate folder. So in our particular case, in order to move on from here, from motion correction, all we need is this VRREF variable, which is undefined for now. So if I'm gonna do VRREF, it's gonna complain that nothing like that exists. So all we need is get this from the hard drive, because we know we already save it to the hard drive. It sort of serve as a checkpoint. All we need to do is to load it back into our kernel or memory. So in order to do that, we can use the load minion function. So I'm gonna say minion ds is equal to load minion. Sorry, apparently I don't remember how I name functions. I believe it's called open minion. So open minion is the function to open the data set. There are other options in here, but basically the most minimal thing you can fit into it is the path of the data set you want to open. So in this case, we're gonna use the intermediate path and let it open. So run this, it should sort of finish. And let's see what's under minion ds. Well, it's kind of boring, but you can see it has a variable VRR, which is kind of the raw video, and a variable called VRREF, which is our pre-processed video. Again, all we need to move on is this VRREF variable. So let's just assign it to the name. So VRREF equals minion ds VRREF. So the minion ds is like a accelerate data set, and the way you access variable in that data set is basically using this kind of dictionary syntax. You basically put it in a bracket and call the name, and that will give you VRREF. So if we run that and we look at what is VRREF, we have our good old array. This is the chunk, the coordinates, everything is there. Okay, is everyone able to get this to work? I hope so. Any questions? Okay, so this is basically what you do when you have a kernel crash. When you lost things in memory, right? You basically go back to a nearest sort of checkpoint, like you go to look for the nearest safe median, and this this sort of require you have more familiarity with the pipeline, because VRF is the only thing we need for now. But if you crash later, there are a lot more variables that's involved. Like when you go to CMF, you're gonna have initial, spatial, temporal, matrix, all those variables. So basically you have much more line, like A equals median DS A, something like that, like C equals median DS C. And you have to sort of figure out what you need for your step and load them one by one. That will require you to read a little bit of code and get familiar with pipeline. But in general, this is what you do. Like you open it up, you load stuff from intermediate folder. If you need something from the actual save folder, I guess you can do median ds final equals open median, like I think it's median ds pass. So that will give you another data set that's kind of reading the final output location of median in case you need variable there. But we don't need that out. Again, the only thing I want to say is the general pattern is you load it from hard drive. You all you need is to figure out what variable you need and index them like this. And then you can continue. So, okay, so that's that. And with that, let's go ahead, print out the parameter, run this step, which should take really small amount of time, and go ahead and run the two cell under safe motion, because that's gonna actually take a while. So make sure you run this while we talk. So while it's running, I'm gonna quickly explain what motion correction is doing. Again, it's pretty simple and it's literally parameter free. There's only sort of one bookkeeping parameter that is telling that basically tell the algorithm to do motion correction across the frame dimension. It's sort of bookkeeping, and you don't really need to worry about that. But again, what motion correction is doing basically kind of doing this phase correlation, cross correlation thing between frames. The best estimation of shift is where it takes the maximum correlation, and we just basically do this across consecutive chunks or like frames to keep it simple. The algorithm implementation is a little bit more complicated, but you don't really need to worry about that. So that's basically motion correction. I guess if anything is wrong here, the only thing I can think of changing is subset MC, which is what the math we just defined and we just saved. If your motion is kind of like all hover around 0, but you're sure they're actually in motion, that's not corrected. That means, you probably have some sort of strong feature that's not moving, and that's kind of biasing your motion correction. So you'll probably want to use a subset of it to run motion correction. That's the only thing I want to say about motion correction. The only other thing is this prime safe median. That's basically just tell you how are we gonna save the data, of course. It's really simple, like dpass is where the median output is gonna be saved. And there's another parameter telling you whether you want to overwrite stuff if there are data that with the same name already exist. I set it to true. I'm pretty sure it's supposed to be false by default, just to be safe. We don't want to override anything by accident. But for the purpose of this pipeline, we're gonna set it to true. But in practice, be really cautious about setting this to true, because you can literally accidentally run a safe median call and then override some stuff that might be important. So I hope everyone have this step finished just like me. again, this it's a save minion or save minion call that takes time because that's actually where the motion correction is being done. If it's finished, you can go ahead and run this visualization, which is it's kind of like a simple plot. It's basically plotting the amount of shift in pixel unit across the height dimension or width dimension across time. And I guess the only thing you want to look for is that whether everything is sort of hover around 0 and whether there's some crazy shift that's not supposed to happen. So this looks fine. Oh, the other thing is you want to make sure it doesn't really drift because at least in old version of Minion, sometimes it happens. Like you see over a long time, the kind of field of view is drifting towards one side. That shouldn't really happen anymore, but it's something you want to look out for. So this looks fine. We're gonna go ahead and apply motion correction or apply this kind of shift correction to the VR ref. And the result of that is going to be saved as Y because that's going to be the term we use for CMF. And this kind of signify we are ready for the CMF part. So let's go ahead and run that. Again, save result is going to take a while. There's not anything that's really interesting here other than we are saving a lot of copy of Y because later we're going to use different chunking strategy for different algorithms. So we're basically chunking them in different ways right here and put them all in the hard drive. Oh, that was fast. And then let's do some plot. Let's sort of scroll past this plot for 1 second and run the next cell because I know that's going to take a while. And then let's quickly talk about this plot. So this is the max projection of the movie before and after motion correction. So this is before motion correction, after motion correction. They look quite identical right now because we choose a video that basically doesn't really have that much motion. I'm gonna try my best to find a good example. It's particularly hard, again, because we also spatially downsampled. But what you're looking for here to make sure motion correction is functioning properly is that some cell being basically shrink and more well-defined. I'm not sure whether I'm hallucinating here, but this cell looks like, no, not really. I guess we really have a video that doesn't have that much motion, which we sort of already know by the plot of shifts. But anyway, what you're looking for here, if you have a video that actually have a lot of motion to be corrected, is that some cell will kind of look blurry and all over the place before the motion correction. But after motion correction, they'll become much more well-defined and their border will be much cleaner compared to before. And that is, if you think about it, that makes total sense because, that's because we are taking the max projection across the whole time. And before motion correction, if a cell moves to a different place, they're essentially going to show up as two cells in some cases, in the extreme cases. But if we correct everything properly, they're going to kind of go back and merge into one again. And that's the best way you know whether motion correction is doing properly. Sadly, I'm going to give up finding a good example for you, but this at least it serves as a sanity check for us. At least we don't have crazy duplicated cells or like anything that's weird happening. The other thing you can do, oops, thankfully this block finished, is that you can look at a video that's before and after motion correction. So if your cell is already finished like me, you kind of print out the path to the video. Let us go ahead and try to find this video in our cloud instance. I'm gonna switch to the other tab where we are kind of in this file explorer. I believe the video is located under demo movies, Minia MC. If you're running this locally on your computer, you can just basically go ahead, find this in your file explorer and just play it. But everything is on cloud right now, so I'm just gonna download this MP4 video. That's fast. And open with my sort of favorite video player. I don't know how much you can see, but on my screen, there's a tiny bit of shaking on the left side. That is the video before motion correction, but it's quite stable on the right side. You can probably not see anything from my screen. So if you want to see this in action, go ahead and do what I just did. Go to this folder and download this video and play locally on your computer. But in any case, this is another quick thing you can do to check whether motion correction is functioning properly, because you can really see the tiny shaking shifts with your eye in a video, which is hard to see with any other visualization. So I'm gonna close this now and go back to my pipeline. I believe that's actually it for this section of the pipeline. Again, motion correction is kind of pretty quick. I'm happy to take any questions, and we are basically ready for a second breakout so that we make sure everyone is still on the same page. Any questions?
Hey, Phil.
Yes.
Can you comment on, since this is parameter free, if there's some fake or false positive detections of motion, how something like that can be addressed? Or do you not expect that to occur?
I really don't expect that to happen anymore. The only thing I see after all the update this year is that I think it happens when you have a, okay, let me back a little bit. Actually, let me pull out the video. Ready to go. Okay, this works fine. Let me. So as you can see here, the kind of the data, the source of motion correction is basically all the cells, because we do this after background removal. So there's no, any sort of blood vessel or any kind of blob background left for motion correction to grab onto. So we're basically using the cells themselves as a landmark for motion correction. And one thing that can happen is that in some frames, you basically have one or two cells that's kind of firing, and the motion correction is going to kind of latch onto those one or two cells. And when we have so few number of cells that's firing, or if the frame is so dark that you basically have some random noise, motion corrections can sometimes go crazy, because you're gonna have a max correlation at some crazy shifts that doesn't really make sense, but it is just what it is, because somehow your noise or your one or two cell happen to correlate with each other, like they happen to kind of have a high correlation with that crazy amount of shift. So the only time I see that happen is if your video is really, if you have some frame that's really dark, you basically have some sort of random background or something that I don't really know what it is, and that will give you a crazy shift in the plot. It's really rare, but when it does happen, I usually just go ahead and run these visualizations, and as long as you can see in the max projection that you don't have duplicated cells, basically, because if you have cells firing and motion correction is not doing its job, and it kind of shifts cells to a random crazy location, you're gonna see that in the max projection. You're gonna see them being duplicated here. So as long as you don't see that, and if you really want to make sure what's happening, go to the frame where the crazy frame happens, and see whether it's actually being darker. Usually it's basically nothing happening. So as long as you can make sure that's what's happening, right? It's a black frame. It has a crazy shift, but it's not really influencing anything. It should be fine. You can just keep going. If not, we'll have to see. I have to figure out what happens. But yeah, the parameter should be kind of already set for 99% of cases.
Cool, thank you.